Hey everyone, today we are going to talk about chemical equations and balancing these chemical equations. So a little bit of review. This didn't come out well. In a physical change versus chemical change. So in a physical change, the original substance still exists. It only changes form. So stuff like melting an ice cream, right? You still have the same thing. If you melt ice, you still have H2O. But in a chemical change, you get a new substance. So that's the key thing here, is that we get something new in a chemical change, whereas in a physical change, it stays the same. And the notes will show up better than this. Okay, so here are some examples. When something dissolves, that's physical. If they undergo a chemical reaction like decomposition, that's a chemical change. When a match is ignited, that's a chemical change. When iron rusts, that's also a chemical change. Remember, we can tell because the color changes. That's one way of telling a chemical change from a physical one. Okay, so what is a chemical equation? It's a representation of a chemical reaction that uses symbols to show the relationship between reactants and products. Okay, so methane plus oxygen, arrow, carbon dioxide plus water. What this means is methane and oxygen react to form or produce carbon dioxide and water. So if we look at this equation, it looks like this, CH4 plus O2. And so we have the reactants on the left side, and we've got products on the right side. Okay, so here's our methane, we've got oxygen, and we're forming carbon dioxide and water. Okay, I know it's a little hard to see here, so make sure you look over the notes. Okay, remember that a catalyst helps make a reaction go faster, but it's not directly involved in the reaction. So here we put the catalyst on top of the reaction arrow. We say that hydrogen peroxide decomposes in the presence of manganese oxide. I'm going to show you a demo tomorrow that involves a catalyst. Okay, sometimes we need heat to get a reaction going. So if we do, we're going to place a triangle or the word heat above the reaction arrow, as you see here. So calcium carbonate decomposes when heated. All right, so the main thing I want to talk about today is the law of conservation of mass, which tells us that mass cannot be created nor destroyed. In other words, atoms cannot be created or destroyed. What you start with is what you end with. So we should have the same number of atoms that we started with in the very end of our reaction as well. So a little review here, a little math review, right? What do we call this number in front of the x? Well, that's called a coefficient. And what do coefficients do? They're used as multipliers. So in chemistry, they do the same thing. So here, if we put a 2 in front of H2O, right, that's multiplying however many waters we have. So now we've got 2 water molecules. And so in total, in 2 water molecules, there are 4 hydrogens and 2 oxygens, right? I can count them right here. Okay, so this is going to be important for balancing equations. You need to be able to count all your atoms correctly. So again, that 2 gets distributed to both of these numbers, and we end up with 4 hydrogens, my bad, and what we have is 2 atoms of oxygen. So we are going to practice balancing equations, and so there are 6 steps that we need to follow. First, look at the reactants and products. Then we're going to count atoms for both sides. So remember, reactants are going to be on the left side, products are on the right side of the arrow. So sorry. So drawing a line there helps. We're going to insert coefficients to balance these reactions. So coefficients are going to go in these blanks here, and then we're going to update the numbers to make sure that it's the same on both sides. We may have to repeat these steps until all the atoms are balanced. Okay, and then lastly, you want to check your work. So I'm going to go through 2 examples with you. Hopefully you can go back if you need to, or watch other videos if you really have to. But let's take a look at this reaction here. So the first step you want to do is, again, reactants are on the left side of this arrow, products are on the right side. So just make sure you understand that. And then you want to count, how many atoms do I have to start with? So on the left side here, I've got 2 hydrogens. I've also got 2 oxygens. On the right side of the arrow, I've got 2 hydrogens, but only 1 oxygen here. So is it balanced? Well, we can see that the hydrogens are balanced right now, but the oxygens are not. So what can we do? Well, we can add coefficients to make it balanced. So if there's only 1 oxygen here, I'm going to have to add a number in front of here to make sure that there are 2 oxygens. So the number I'm going to put is 2. And what that does is that's going to multiply all my numbers here. So now I want to update my table down here. So I'm going to cross this out. And now I've got 4 hydrogens and 2 oxygens. So the numbers are updated after I put the coefficients, but now I see that I don't have a balanced number of hydrogens. So this is no longer balanced. This is good. So now I'm going to go back to the left side, and I want 4 hydrogens total. So I'm going to add another coefficient to the left side. I'm going to put a 2 in front of hydrogen. And what that does is that gives me 4 hydrogens there. I've got 4 hydrogens on the right side, 2 oxygens on the left side, 2 oxygens on the right side. Everything is balanced. I'm going to put a 1 here just to make sure I have a number in front of each of these reactants and products. And if we do a final count, we can see that these are indeed balanced on both sides. Okay, so make sure you're updating your numbers after you put those coefficients. All right, let's go and try another one. This is the first one. This is the second example down here. Okay, so first thing you want to do is just take an inventory of all the atoms that we have. So I have 2 lithium atoms on my reactant side. Again, reactants are everything on the left side of the arrow. Products are everything on the right side of that arrow. I've got, so here I've actually got 1, 2 oxygens. I'm going to put a 2 there. Make sure you're counting both of those oxygens on the left side. And then for hydrogen, I've got 2 as well. So those are my reactants, right? Everything on the left side here. Now I can look at lithium hydroxide on the right side, and I'm going to count these. So I've got 1 lithium, 1 oxygen, and 1 hydrogen. Okay, so now oops, 1, 1, and 1. So to balance this, clearly I need to change the numbers on the right side. So I'm going to put a 2 in front of this, and that'll change all of these to 2. I look at my numbers, and they're all balanced. I can put 1s in front of here. And that's how you balance equations. Again, the coefficients are the only ways you can change the numbers, and then you want to update your numbers on your table, and then make sure you fill in the rest of the coefficients as well. All right, I hope that helps you understand how to balance equations. As always, please ask questions if